In this video, we're going to talk about solving systems of equations using matrices. And let's go back to some examples. So suppose you have the following system. Let's say it this way, rate the following system in the form A x equals C, where A and C are matrices. And X is X, Y, Z, like this. So let's take a look at this. So say we have 4x minus y plus 2z is 6, 2x plus 3y minus z is minus 7, minus 5x plus 10y plus 8z equals 1. So we want to write that in this form up here. And so what it really means is we're kind of going to take out x, y, and z. And so, for example, we can write this 4 minus 1, 2, 2, 3, minus 1, minus 5, 10, 8, like this. X, Y, Z, like this. And then notice that you could multiply this out and get the above. In other words, if you multiplied this vector in, you would get this, this, and this, except we also need the right-hand side here. And we have it like that. So just sort of, in effect, factor out this vector x, y, z, and put the right-hand side as a vector, and then have our matrix here. Let's do the same thing for this set of equations. Let's say we have 3x minus 7z equals 2, y plus 4z equals 8. X minus 6y minus 2z equals minus 10 like this. We can do it in a similar way as the last example, except notice up here we don't have any y's. So when we're factoring this out, you'd have to think of this as being 3x, 0y, minus 7z, 0x, 1y, 4z, 1, minus 6, minus 2, like this. then we have x, y, z equals 2, 8, minus 10, like this. And once again, this is going to be our, what we're calling up here, this is going to be the matrix A, this is the matrix C, and this is the matrix X. Now we want to do all of this because we're interested in solving these systems of equation. We want to find X, Y, and Z. And let's take a look at how we're going to do this. Again, let's look back to algebra. Recall, to solve this simple equation, let's say you had like AX equals C, where A, B, and C are scalars, numbers that is. And so let's think how we would solve this. Now, a lot of times we skip steps when we solve this, but let's look at going through all the steps if we were to be real rigorous. So we would start by multiplying both sides by the inverse. So we would multiply the left by a to the negative 1. And over right-hand side, a to the negative 1. Then, of course, remember, when you multiply anything times its inverse, that's just going to be 1. Or, of course, 1 times x is just x. So we have this. So let's go ahead and solve a simple equation using this. So let's say solve 7x equal 10. We're going to put in all the steps. Again, usually we don't do this. We usually skip a lot of steps. So again, if we're going to start with this, 7x equal 10. And then what we do, we multiply by the inverse of 7. And of course, 7 times 1 over 7th is 1. So it's going to give us 1x or x. And then on the right-hand side, we have 10 over 7 like this. That's a very rigorous way to solve a simple algebraic equation. And we're going to use the same understanding to help us solve similar equations with matrices. So let's consider AX equals C. Again, where A and C are matrices. And of course, this is going to be like XY or XYZ, depending on how many dimensions we're in. And so let's solve this. And so let's do what we did a minute ago. Let's multiply both sides by the inverse of A. The only thing we have to be careful of when we're dealing with matrices is they don't necessarily commute. In other words, you can't often switch order. So if we multiply on the left by A inverse on the left-hand side of the equal sign, we also have to multiply on the right. On the right-hand side of the equal sign, we also have to multiply C on the left, like that. In other words, we multiplied it on the left over here, multiply it on the left over here. And just like before, we get, remember, A inverse times A is the identity. And this, of course, the identity times anything is the anything. And we have this. And like I said, this is going to be the X, Y, and Z, or X, Y, depending on how many dimensions we are, that's going to solve our equation. And again, we're going to use this to solve systems of equations. Let's take a look at this problem. We want to solve this system of equations. It's a simple system of two equations after first setting up AX equals C. So let's go ahead and solve this. Again, let's go through the steps like we did before. So first, let's rewrite this in this form. Remember, A and C are matrices or vectors, really the same thing, except, vectors are like, we'll only have like one column. So let's write this as 2 minus 3, 1, 4, x, y, 7, 12. Just writing it the way we did previously. And to remember, this is A, this is our capital X, this is C. So much like before, we're going to need to solve this. And we showed a few minutes ago that we can solve this by multiplying both sides by A inverse. And then we end up getting X equal A inverse times C, like this. So now let's go ahead and find A inverse. We know how to do that from before. So again, if we have A is equal to 2 minus 3, 1, 4, we can find the inverse by first finding the determinant of A, upper left times lower right minus upper right times lower left. And that's going to be 8 minus a minus 3. That's going to end up being a positive 11. Then A inverse is going to be, again, 1 over the determinant. And then we switch the order of these two. In other words, they change places. And we switch the signs of these two. Like that. This went from negative to positive. This went from positive to negative. And that's our inverse. And again, sometimes it's helpful to multiply this through. Sometimes not. Sometimes it's easy just to leave it on the outside. For now, I'll just go ahead and leave that on the outside. So again, let's solve for x by using what we have here. X is equal to A inverse C in our case. And let me write what x actually is. That's x and y. And then C was 7 and 12, like this. And like I said, it might be helpful just to leave this scalar outside. So again, let's multiply this through. Multiply this times this. So that's going to be 28 plus 36. And then this times this column, minus 7 plus 24. And this is going to be 1 over 11. And what is that? 64. And this is 17. And finally, maybe after we're done, have finished all the calculations, then we may multiply the 1 over 11 inside. So what does this mean? So our answer is x equals 64 over 11. Y is 17 over 11, just from following this right here. So again, find the inverse of the matrix, multiply it times C, and that gives you your answer. Of course, this method can be used for any size of system of equations. You could have 3 equations, 4 equations, 10 equations. The only thing is when you get to larger numbers of equations, finding the inverse of the matrix takes more time and much more tedious. Let's do, let me do one more example of the two-dimensional case. Again, if you don't need this extra example, I would just skip this one. This is because this is similar to the last one, but let me just go through this quickly in case you do need another example. Let's just solve this. And just like before, sort of factor out the x and y. And then this is our matrix A. This is our matrix X. This is our matrix C. And then A is 2 minus 4 minus 3, 1. And then determinant of A, upper left, lower right, minus upper right, lower left. And this is 2 minus 12 is minus 10. And then remember our inverse is 1 over minus 10, 1 over the determinant. Then always trade places with the upper left and the lower right. Change the sign of the upper right and the lower left. Like this. And again, sometimes it's helpful just to keep the scalar outside. And so I'll do that in this case, just keep it outside and won't multiply it through at the moment. And just keeping in mind what we're solving for, we're solving for this. And we know, again, in our case, this is the x is going to be just x and y because we only have 2 equations and 2 unknowns. And A inverse we found was minus 110. 1, 4, 3, 2. That was A inverse. And C was 1, minus 8 minus 3. Like this. And go ahead and multiply these out. This is going to be minus 8 minus 12 minus 24 minus 6. And that's going to be minus, what is that going to be? Minus 20 and minus 30. And we divide each of these by 10, by a negative 10. So we get 2 and 3. So that means x is equal to 2 and y is equal to 3. So that's solving systems of equations using matrices.